Hello, calculus! So we had a significant number of questions on the rules of derivatives and on combining them. And so I thought the best thing I could do is just to do your homework for you. So now you've all hopefully tried section 3.3, 107 to 117 odd. I'm going to go ahead and do from 107 to 117, all 10 of them, just to give you a little bit of extra practice. So you can follow along with me, or you can just skip ahead to the problems you had questions about. And let's get going. Let's do some derivatives. So 107, you're given f of x is equal to x to the 7 plus 10. And you want to find f prime of x. So the nice thing here is that because the derivative is based on the limit laws, if I have a sum x to the 7 plus 10, I can look at f prime of x. I can take the derivative of this piece by piece and first take the derivative of x to the 7th. I'm going to do that using my power rule. So that'll give me 7x to the 6th. And then I can add to that the derivative of 10. And the derivative of all constants is just 0. So that's 7x to the 6th plus 0. Of course, the simplest way to write this is f prime of x equals 7x to the 6th power. Final answer. For number 108, you're given the function f of x cubed, f of x equals 5x cubed minus x plus 1. So I'm going to take this chance to show you another form of notation. So I'm looking for the derivative. So I could say f prime of x is equal to the derivative with respect of x of 5x cubed minus the derivative with respect to x of x plus the derivative with respect to x of 1. This notation that I'm using, this d by dx notation, this is a fancy way to say what I told you for problem 107, which is that when I'm taking the derivative of this function, I can take the derivative of each piece of this polynomial, each term, and then add them all together, and that'll work just fine. So the derivative with respect to x of 5x cubed is 5 times 3x squared. The derivative with respect to x, remember this x has an invisible exponent of 1. So this would be minus 1 times x to the 0. And then derivative with respect to x of 1 is a constant of 0. So this should be equal to 15x squared. Remember that anything raised to the 0 power is equal to 1. This is subtract 1. You don't have to do all of these steps. I'm just showing these here for those of you who are practicing some calculus during a pandemic and you need to see all the steps. I don't blame you one bit. And that would be our f prime of x for 108. So here we have for 109, f of x equals 8x to the 4th plus 9x squared minus 1. So f prime of x will be 8 times 4x cubed plus 9 times 2x minus 0. That'll be 32x cubed plus 18x. So f prime of x for 109 is 32x cubed plus 18x. And that's our final answer. Hope this is helpful for you. It's kind of relaxing for me, to tell you the truth. Nice to do something that I understand during these crazy times. All right, so 110 is where it starts to get hairy. So f of x is equal to x to the 4th plus 2 divided by x. I'm going to rewrite this function so that I can use the power rule, because I know how to do this part of the derivative, okay? I feel pretty good about using the power rule, but when it comes to this, I'm a little bit nervous. So here's how I'm going to rewrite this function. I'm going to say, look, this is the same as saying f of x is equal to x to the fourth plus 2x to the negative 1. Now I can use my extended power rule. So remember, the power rule says that this exponent becomes your new coefficient in both cases. And then to get your exponent you subtract from there. So let's take a look. So this is going to give me 4x to the 4 minus 1 plus 2 times negative 1, x to the negative 1 minus 1. So we get 4x to the third minus 2x to the negative 2. And I can change that notation into saying 4x cubed minus 2 divided by x squared. That'd be my final answer. If you're a little bit lost as to what I'm doing with these negative exponents, what I'm doing is I'm applying the negative power rule of exponents. And you can review that, and that'll help you out. Great. All right, so let's move it along. Feel free to pause this video or replay parts of it. I know that I'm going quickly because I don't have you guys to stop me here with questions. So don't be afraid to go back, watch it a couple of times, you know, whatever you need to do. And if you still have questions, please do let me know about a particular step. All right. Where were we? Okay. We're at 111. So let's say I have f of x equals 3x times 18 x to the fourth power plus 13 over x plus 1. This is where we start to get into some interesting questions, because there's actually more than one way to do this. So one thing I could do, if I felt like it, is I could distribute this 3x in and then take the derivative, or I could use the product rule and take the derivative of each of these. In this case, I think it's simpler to distribute this in first before I do anything else, and then take the derivative. So this is going to give me, let's see, 3 times 18 is 45 plus 9 is 54. So I get 54x to the fifth plus 39x divided by x plus 1. And now when I take the derivative, remember that if I'm taking the sum, if I have the sum of two terms in here, then I can take the derivative of this, the derivative with respect to this, and I can take the derivative with respect to x of this, and then I can just add those two together. So then the derivative with respect to x of 54 x to the fifth is going to be 5 times 54 x to the fourth power. So that's going to be 270 x to the fourth power. The second piece is a little more complicated. The derivative with respect to x of 39x divided by x plus 1 is going to require us to use the quotient rule. So we're going to need to know, for the quotient rule, the derivative of 39x, the derivative of x plus 1, and we're going to use those things to help us. So in yellow, the derivative d by dx of 39x equals 39. In red, the derivative d by dx of x plus 1 is equal to 1. And now we're ready to use our quotient rule. So this derivative here is going to equal to, they have a little song for this. They say low d high times high d low. You know what, guys? What I'm doing right now is I'm Googling quotient rule in calculus. Because I use a secret trick involving the product rule that I'll show you. After we cover the chain rule, I'll show you my trick. I never use the quotient rule in my personal life. I always use the chain rule and the product rule together. But when I'm teaching you guys, it's important to know the quotient rule and understand it, because some people use the quotient rule and you're going to need to be able to communicate with them about mathematics. So here's what we're going to do. That low d high, high d low thing means you take the low function, the function that I have here in red, and copy it. Then d high means the derivative of the high function, the derivative of the function I have in yellow, and you multiply them together. And then you subtract high d low. So you take 39x, the derivative of the, or you take the numerator without taking the derivative, just the numerator, and you multiply by the derivative of the denominator, which is 1 in this case. And then that's all over the denominator squared. So this is our derivative, and we can simplify this a little bit here. We get 39x plus 39 minus 39x. This is me just distributing in here. All divided by x plus 1 squared. The x's cancel out here, and I'm left with 39 over x plus 1 quantity squared. And that's my final answer. I hope this is helping you guys. Let's go and try another here. Let's do 112. If you're like, wow, how is she going so fast? Guys, I've been doing this for 10 years, okay? You should not be worried if this took you a long time to cover. It's some of you, it's your first time seeing it, and it's not like you don't have other things going on in your life right now, okay? You're going to have to be really patient with yourself during this semester. So 112, they give us this function. F of x is equal to x plus 2 times 2x minus 3. I could choose to combine these together and then take the derivative afterwards of a long polynomial using only the power rule, but that's going to give me a lot of room for algebra mistakes. So instead, I'm going to use the product rule. The product rule states if I have a function h of x is equal to f of x times g of x, then h prime of x equals f prime g plus f g prime. So what I'm going to do is I'm going to say this red piece is my first function, and this green piece is my second function. And then I know that what I'm going to do is try to find the derivative, and so I'm going to need to find the derivative of each pieces of those functions. So let me show you how I organize my work when I do this. I'm going to erase these formulas here. A lot of these problems are just about organizing your work well. So I know if I take the derivative with respect to x of x plus 2, that should be 1. This constant becomes 0. This x becomes 1. If I take the derivative with respect to x of 2x minus 3, I get 2. The derivative of this constant becomes 0, and the derivative of this term 2x just becomes 2. Okay. So now I'm looking for f prime of x. And I want to do first the derivative of my first function, which I have right here, is 1, times my second function, 2x minus 3. I'm going to add to that the derivative of my second function, 2, times my first function, x plus 2. Then I can simplify 2x minus 3 plus 2x plus 4. And I end up with 4x plus 1. And that's my derivative here. That would be my final answer. So let me box that for you guys. F prime of x equals 4x plus 1. All right, so 113 is a slightly more complicated version of this same idea. So I have f of x equals x squared times 2 over x squared plus 5 over x cubed. And this is a fun one because I can take the derivative using the product rule the same way I did before, or I can distribute and do that. I'm going to choose in this case to distribute because I only have a monomial times a binomial, and something kind of interesting is going to happen once I distribute. I'm distributing this x squared, and I get f of x is equal to 2 plus 5 over x. And that's because when I multiply the x squared into my first term, I have x squared divided by x squared. And when I multiply it in here, I'll have x squared divided by x cubed, which will leave an x on the bottom. Okay, so now I can take f prime of this, but you know, remember how before I used the negative exponent law so I could use the power rule? I'm going to do that again. F of x is equal to 2 plus 5 times x to the negative 1. And then f prime of x, the derivative of 2 is 0. And then I can use my power rule here. Plus 5 times negative 1 times x to the negative 1 minus 1. And I'll simplify. F prime of x equals negative 5 x to the negative 2. And I'll simplify again and say f prime of x equals negative 5 over x squared. And that's my final answer there. A lot of these, I'm sure, as soon as you see the trick that I do, you go, well, if I'd thought of the trick, I would have been able to do it. Calculus is notorious. Oh, this is actually 114. Calculus is notorious, actually, for that at all levels. A lot of calculus involves kind of this tricky puzzle-solving mentality where you have to keep looking for little things that you can do to make a problem easier for yourself. So we have x cubed plus 2x squared minus 4, all divided by 3. This one's a big algebra trick here. That means the same thing as saying 1/3 times x cubed plus 2x squared minus 4. And now I can distribute this to each term. So I can say f of x is equal to 1/3 x cubed plus 2/3 x squared minus 4/3. By the way, there's multiple ways to do a lot of these problems, so if you do it differently, don't worry. As long as you get the same answer, you're probably fine. And now I can take the derivative of each term because we're using addition to combine them. So because the sum of the limits is equal to the limit of the sums, the sum of the derivatives is equal to the sum to the derivative of the sum. So I'm going to use my power rule here, and I'm going to be very careful with my fractions. So I have 1/3 times 3 x to the 3 minus 2. Oops, 3 minus 1. Plus 2/3 times 2x to the 2 minus 1 minus a 0. F prime of x, I'm going to simplify this out. 1/3 times 3. These 3's are going to cancel, and I'm going to be left with x squared. 2/3 times 2 over 1. I'm going to multiply numerator to numerator and denominator to denominator. And I'm going to get 4/3 x. And that's it. It's my final answer right there. You could arrive at this by using the quotient rule. I think it's a lot harder. I think it's easier to manipulate the algebra here. But if you did it by the quotient rule and you got the same answer, you know how I feel about that? Yeah, I'm excited about that. All right. So let's take a look at 115. So let's say I have f of x equals 4x cubed minus 2x plus 1 divided by x squared. I could use the quotient rule here. I could, but you guys know how I feel about the quotient rule. So I'm going to use an algebra trick very similar to the one I just did. Very, very similar. And I'm going to say f of x equals 1 over x squared times 4x cubed minus 2x plus 1. And then I'm going to distribute. F of x equals 4x cubed over x squared minus 2x over x squared plus 1 over x squared. And I'm going to use my laws of exponents to simplify here and here. And so I'll have f of x is equal to 4x. Again, I'm going to simplify using my exponent laws here. Minus 2 divided by x plus 1 over x squared. Now I'm going to use my negative exponent law. I'm going to say minus 2x to the negative 1 plus 1x to the negative 2. Now I can use my extended power rule. F prime of x equals 4 minus 2 times negative 1, x to the negative 1 minus 1, plus 1 times negative 2, x to the negative 2 minus 1. Make sure those negative signs are visible for you. And then I'll get f prime of x equals 4 plus 2x to the negative 2 minus 2x to the negative 3. So f prime of x is equal to 4 plus 2 over x squared minus 2 over x cubed. And that is a perfectly acceptable, beautiful answer for this problem. Let's take a look at 116. You'll notice here that there's a pattern, which is I'm using algebra to make things as simple as possible. And I know some of you are like, oh, but algebra sucks. And I really, truly hear you guys. I really, truly know that algebra is difficult. And it's okay if you don't see all of the tricks that I'm using. If you did the problem a different way or a longer way, or if you have to go look up algebra facts and remind yourself of how you can actually simplify these type of equations, that's okay. It's just going to be a matter of practice. And the longer you practice, the better off you're going to be. All right, my loves. Okay, this one, there is no escaping the quotient rule. There's no escaping it. So I'm going to have to suck it up and do the quotient rule. And remember the quotient rule says this. If I have a function h of x and it equals f of x over g of x. Then h prime of x is equal to g of x times f prime of x minus f of x times g prime of x all over, if I take that denominator, g of x, and I square it. So again, this is a nice way to organize your work. When they're talking about f of x, that means this numerator function here. When they're talking about the denominator g of x, they're talking about x squared minus 4. So I like to go ahead and organize that work that way. So here, f of x is equal to our numerator, x squared plus 4. And I know that I'm going to need to know the derivative of that function. So f prime of x will be equal to 2x. And g of x is equal to the denominator of that function, x squared minus 4. So g prime of x will be 2x. They also want to know g of x squared, which should be x squared minus 4 squared. And I'm happy if you just leave it like that. I don't think you really have to simplify that much. So now I'm going to use all of these little pieces that we have to figure out what the derivative of this function is. I'm going to plug them in. So my quotient rule says first comes g of x. Here's my g of x. So first comes g of x, x squared minus 4. Next comes f prime of x. There's my f prime of x. So that's what I put. Then I subtract the product of f of x and g prime of x. And then I divide all of that by g of x squared. And then now what I have to do is a lot of simplification. Okay. So what I see is 2x as a common factor. To use red as a highlighter. I see that I have 2x as a common factor here and here. And so I'm going to factor that out and say I have 2x times x squared minus 4 minus x squared plus 4 all over x squared minus 4 quantity squared. And now I'll distribute this negative in the parentheses here. I have 2x times x squared minus 4 minus x squared minus 4 all over x squared minus 4 quantity squared. So x squared minus x squared gives me 0. Negative 4 minus negative 4 gives me negative 8. So I have 2x minus 8 times negative 8, all divided by x squared minus 4 quantity squared. And that gives me negative 16x over x squared minus 4 quantity squared as a final answer. All right, now we're down to 117, our last problem. I hope this has been helpful to you guys. F of x is equal to x plus 9 over x squared minus 7x plus 1, I see a quotient, so my mind thinks quotient rule, but you know I hate quotients. So I'm going to see if I can simplify this statement at all, and if I can actually factor x squared minus 7x plus 1. And if I can, I'll be very happy. But you know, I don't think I actually can. I think this is prime, because what I'm looking for here would be factors of 1 that add up to -7. I don't know any numbers like that. Oh, boo-hoo. I have to do the quotient rule. Now let's go ahead and do the same method I did before. So if I'm going to rename this function actually from f of x to h of x, just so that it'll fit with our beautiful quotient rule a little bit easier. Some of you asked how you memorize rules and things like this. When I'm doing homework, when I was memorizing the quotient rule, anytime I used it, I would rewrite it in my homework. So that helped me memorize as I went, and it also helped me just keep my work neat and stop myself from making mistakes. So the quotient rule says that h prime of x is equal to oh, sorry, I forgot to say what h of x is to begin with. If h of x equals f of x over g of x, then h prime of x equals g of x times f prime of x, I have to move my palette, minus f of x times g prime of x, all divided by g of x squared. So, just like before, I'm going to go piece by piece. I'm going to say, here is my f of x. And here is my g of x. So, f of x equals x plus 9. And then I take the derivative of that. I get f prime of x equal to 1. G of x equals x squared minus 7x plus 1. And g prime of x is then going to be 2x minus 7. And so I can plug all of this in here and now say h prime of x is equal to my function g of x, which is here, x squared minus 7x plus 1, times my function f prime of x, which is right here, which is just equal to 1. So I'm not going to even write it, because multiplying by 1 is using the identity, so we don't need to worry about it. And then I'm going to subtract, that was my f prime of x, and then I'm going to subtract f of x, which is this function right here, x plus 9, times g prime of x, and g prime of x is this function right here, 2x minus 7. And all of that is going to be divided by my g of x function squared. So here's my g of x function squared. I see that there's some simplifying I can do here, because if I multiply these two binomials, I will get a quadratic, which will probably simplify a little bit with this quadratic here. So I'm going to go ahead and do that. X squared minus 7x plus 1 minus, I'm just distributing here, 2x squared minus 7x plus 18x minus 63, and that's all over x squared minus 7x plus 1 quantity squared. So now I can go ahead and simplify and get x squared minus 7x plus 1 minus 2x squared plus 11x minus 63 all over x squared minus 7x plus 1 quantity squared. I'm going to collect my like terms here. So I see that I have an x squared and a 2x squared, a negative 7x and an 11x, and a 1 and a negative 63. And don't forget, this negative sign is going to distribute and change the signs all in here. So what I'm going to end up with is negative x squared minus 18x plus 64 divided by x squared minus 7x plus 1 quantity squared. And that's my final answer. Whew! I hope that watching that video helped you understand a little bit about how to apply these differentiation rules. These take practice. I'm writing it on the board, it's so important. These take practice. Keep going. I hope you guys are well and safe. I miss you. Stay safe.